You can use the values of the derivative at a specific point to determine whether a function is increasing, decreasing, or stationary. Now, how do you do that? This is what you should know. Let's look at this. If I gave you the function of f of x is equaling to 2x cubed minus 3x minus 12 alongside, so it represents the following graph here. And I say, when x is equal to minus 2, let's go and check x is minus 2. We expect x to be minus 2 to be somewhere this side. Okay? So this can be minus 1. If we say this is minus 1, we expect minus 2 to be somewhere this side. And then I can ask you, what is happening to the function? Is the function increasing or decreasing? Here's what Elena can do. Ne? Elena can use, they can determine by calculations whether a function is increasing or what, or decreasing. Now, what kind of calculation is Elena going to do? Elena can differentiate. Let's differentiate this thing. If you differentiate, what are you going to have? F prime of x is equal to 6x squared minus 6x minus 12. Now, as long as you have the derivative, child, what we're going to do is this. Let's check here. We said minus 2 here. What do you think is happening to this graph? Is it going up or is it going down? Let's guess first before we go to the calculation. What do you think is happening to this graph? It's getting bigger. Ne? Yeah, if you compare this side, it seems to be getting bigger and bigger and bigger and bigger. So if I say at x is minus 2, here's what I'm going to do. I'm going to say f prime, not f of x, f prime is the one which is going to tell me whether the function is increasing or decreasing. F prime of minus 2. Then I'm going to have 6 multiplied by minus 2 all squared minus 6 multiplied by minus 2 minus 12. I'm going to get 24 if I'm not mistaken. 24. Now, the answer that I got here can either be negative or it can either be positive. Yeah? In other words, here's what I'm saying. The gradient f prime of x can either be greater than 0. Greater than 0 is positive. And then f prime of x is less than 0. It means which is negative. Let's check when x is 0. Let's try to check when x is 0. What kind of an answer did we get here? Positive or negative? We got what? 24, which is positive. 0. Let's check 0 here. What do you think is happening to this graph here? Before, let's guess first. It's increasing or decreasing? So it's getting smaller. Yeah, you can see which is going down. Here at 0 here, so the function is decreasing. But let's check, let's just confirm it. F prime of 0. 6 multiplied by 0 all squared, okay? Minus 6 multiplied by 0 minus 12. We get minus 12. Now, let's check something else then. It seems as if when we get the gradient to be positive, look at this, the gradient is positive here. Okay? Our function is what is increasing. When the gradient is positive at the point, it means this thing here is what is increasing. When the gradient is negative, look at this then. When the gradient is negative, look at this. When the gradient is negative, it seems as if our function is doing what is decreasing. So, in other words, then we can make a conclusion then, Zim, and say, but when f prime of x is greater than 0, the function is increasing. When the gradient is positive, that's what I mean. When f prime of x is greater than 0, then it means the function is what is increasing. At the same time, then, I can say to Ellen, when f prime of x is less than 0, what can you say about this one? Is it increasing or decreasing? It's decreasing. It's getting small. But let's try something else then. Let's try f prime of minus 1. F prime of minus 1, we have 6 minus 1 all squared. Minus 6 minus 1 minus 12. And then guess what are you going to get here? Now, at minus 1, look at minus 1 here. This is minus 1 here. Somewhere here is minus 1. If graph it's here. The graph, it's not increasing, also not what? Decrease. So what can you say about this one then? You can then say something like this chart. You can say f prime of x, when f prime of x is equal to 0, we call it a stationary point. If we don't want to call it a stationary point, we call it a turning point. If we don't want to call it a turning point, we can call it a local maximum. Or we can call it a local minimum. So it can either be turning at the maximum or it can be turning at the minimum. So all those ways that are associated with it. But what is it that I have to see? The gradient has to be 0. If the gradient is 0, we are at the turning point, we are at the stationary point. If the gradient is positive, it means your function is what is increasing. So let's try here. Mind based on what we know. Let's check at f prime of 3. F prime of 3. So it means I'm going to have 6 multiplied by 3 again, or squared, minus 6 multiplied by 3, minus 12. What you get? 20. You get 24. Based on what we just said here. Charlotte, do you think the function is increasing or decreasing here? We got 24. It's decreasing. D. E. Anglayelang Charlotte. Number. Sitya, if gradient is static which all positive. Okay, if gradient is positive, if graph cancer. Yeah, you can come and tell them, it's simple, this thing. They just told us, man. This thing is decreasing. This thing is going down. Because, it's increasing, man. Charlotte, man, I'm going to step by. I'm going to check decreasing. The one on Charlotte. This function is what is increasing. Secret. As zaman x is equal to 2, then f prime of 2. Story 1. Story 0. Okay, what we will say? Increasing, decreasing, or stationary? It's at the stationary. Yeah. Now, with that being said, then, wena izala uzongitshela ukuthi okay, now ama values la. Uzongitshela ukuthi if function there is increasing, decreasing, or at stationary point. Here's your class work now.